This is the CremaLoop Electronic Slow Feeder. I believe this may be the first device of its kind on the market. Today, I'm going to do an overview of what this is and why you may want a tool like it. I'll talk about pros, cons, and quirks of this device, and then I'll do a few demos towards the end of the video. So this device is designed and produced by a company in Switzerland called CremaLoop. So why would you need a device like this? Well, there are a few benefits of slow feeding beans into your coffee grinder. With the design of burrs in a coffee grinder going from a wider opening to a very small opening, what can happen is that the grinds can actually start getting into a traffic jam as they get towards the finer end of the burrs. And then that can create what's called regrinding. And that regrinding effect is not desirable because it can create a number of issues. One of the challenges of it is that it can make inconsistent particle size distribution. Regrinding can also cause additional heat generation, and certainly that's not desirable. You'd like to minimize any heat that's generated during the grinding process. Also, regrinding can create additional static electricity. There's two mechanisms by which static electricity can be generated during the process of grinding coffee. One is by triboelectrification, which has to do with just the individual grinds rubbing against each other, which is similar to maybe when you were a kid, how you could take a balloon and rub it against a shirt and it would create static electricity. And also another process called fractoelectrification, which is where as the individual coffee grounds are being broken apart, it generates additional static electricity. This is a very complex scientific topic, so I'm not going to go into it today. There's a paper that discusses this by Dr. Chris Hendon from the University of Oregon. I'll put a reference into the comments or onto the video here so that you can look it up if you're interested in reading more. So what are the pros of this device? Well, it's a high quality design. You can tell a lot of thought was put into it as they were making it. This is especially true when you consider the fact that this is a device that's basically in its infancy. It has a very simple interface. You just have a single switch on the side that you flip on and flip off to control the feeding of the beans. It does have two different discs in here. This one right here is the standard disc, and it has 8 slots to, as it rotates, as it goes around, it actually pushes the individual beans into a hole in the side, which then feeds through to the bottom. And then if you'd like to slow down the feed rate, this disc here actually covers half of the holes. So you only have now 4 holes. The average time to move 20 grams of beans via the standard disc is 29.21 seconds. So I did 5 runs and averaged them out. So the average is 29.21 seconds. The slower disc averages 50.68 seconds across, again, 5 runs. That's a 73% reduction in feed rate. So even though it's half the holes, it actually isn't half the feed rate. And that would be because the thickness is increased and actually grabs more beans in each individual hole. But one thing that's interesting as I was testing this is that the slower disc, where you just have the 4 holes, has a much higher consistency for its feed rate. The variance is only 1.04 seconds for the slow disc. And that's as compared to the standard disc being 4 seconds of variance, 4.3 seconds. So between the two, that's something to consider. It's not just the feed rate, but also the consistency of the feed rate. Now, what about the cons of this particular device? Well, there's not a lot. I would say that probably the most obvious one would be the fact that it is a 3D printed device. It's nice that it's been able to be fabricated to be such a great design. I'm sure this was something that they were able to start selling so quickly because they did use a 3D printing process. But I'd love to see them start using more durable materials in the future. There are other companies that have started out doing 3D printing and then moved on to using aluminum and sort of high quality plastics in their manufacturing. A couple come to mind are Introvert and Aero Espresso. Also, the capacity is only about 25 grams of coffee. You can see that inside of the hopper here, that the hole that the beans fall through is about halfway up, just over halfway up. So when you have the feeding disc in place, you can only have the beans come up about halfway. Otherwise, beans will actually start falling through the hole when they're not actually being lifted and dropped in. So 25 grams is about all you can fit in here. think ideally it'd be nice if they were able to expand the capacity of this to maybe 30 or 40 grams of coffee for those who are doing, larger batch brews. As far as quirks go, there's only one I can really think of, and that is that the wiring that's underneath of the battery compartment here is somewhat in the way. If you notice here, there's individual wires and they can get caught as you're shutting the cover on the back of it. So something to keep in mind, just be careful not to smash or potentially cut the wires as you're putting the cover back on. So minor quirk, but it is something that I did experience. Now there are two other considerations that I want to put out here that aren't necessarily pros or cons, but just something to think about when you're considering getting this device or perhaps in the future one like it. If you have a lower RPM grinder, a much cheaper alternative to a device like this is something that's been out for a while, and it's just a slow feeding disc. It's very inexpensive. They're available from many different sources. They don't fit on all grinders because one of the requirements is that the grinder does have to have a center shaft for that disc to go onto. But if you do have a grinder that's low RPM and has that center shaft, those discs work very well for this purpose of slow feeding. Obviously though, when you consider this device versus one of those discs, this does give you additional control because you have the ability to get more granular control over the feed rates of the beans. Another thing to consider when you're looking to get a device like this is whether or not your grinder has torque sensing auto shut off. Some grinders, when they sense that there's not many beans in the chamber, or more specifically, that there is a significant reduction in the torque application, then after a few seconds, it will shut off. The thing about a slow feeder like this is that because it's feeding in the beans slowly, with some grinders, you may have challenges related to it wanting to shut off while you're using this. If it's a variable RPM grinder with that auto shut off, you can actually just reduce the RPM down lower so that there's additional time for the beans to grind before they exit the burrs. And that should alleviate any issues related to the torque sensing with your grinder. You just need to test it out and see if it works. Another thing that's nice about this is that the company CremaLoop is designing it with a number of different grinder specific attachments. This one I purchased was actually designed to fit on the DF series, like the DF83V and some others. This specific diameter is the reason I chose it. I don't currently have anything in the DF series of grinders. I knew I could use this across multiple grinders, so that's why I purchased this specific one. But they have ones that are made specifically for a variety of different grinders, even some commercial grade grinders. Now let's go ahead and do a demo of how this works. I have a little stand here that I'll set up so you can see how it actually feeds the beans in. I have 20 grams of beans here to the side. And let's show how, first of all, it feeds it in. You can kind of see the rate, and then I'll actually use a grinder to show how it grinds. So you just flip on the switch, and the beans are rotated upwards and around to the feeding hole where it drops down into the grinder, or in this case, into this glass. And there you have it, it's done. So now let's actually put it onto a grinder. Also, this grinder I'm pulling over is a variable RPM grinder. So I'll have a little tip around how you can adjust the RPM based off of how this is feeding the beans in. All right, now that we have our grinder set up here, I'll go ahead and plug it in. I'll turn it on. I'm going to set it initially at its lowest grind speed, which is 500 RPM. So now we've got the grinder set up. I have it so you can see as the beans are sort of being pulled up around through the electronic slow feeder. I've got the same 20 grams of coffee ready. So I'm going to turn on the grinder and I'm going to set it at 500 RPM. Ideally, the beans would be able to clear the burrs before the next beans drop in, or really, really close to it. So that would help minimize that regrinding effect. That's one of the advantages of using a variable RPM grinder with a slow feeder like this, although it's certainly not a requirement. So I'm going to go ahead and start this up and feed the beans in. So let me first pour the beans into the hopper here, and then we'll turn on the feeder right after the grinder. There we go. So at 500 RPM, it's continuously grinding. So I'm going to turn it up just a little bit. There we go. At 800 RPM, you can hear complete grinding in between each drop. In fact, I might be able to go a little bit slower. Even at 700 RPM, it's able to clear the burrs between each bean drop. So that's how it works. I really do recommend this device. It does a good job, especially for a device that's in its infancy here, being the first one on the market like it. They've done a nice job. I would recommend getting it. So happy brewing.